All right, we're good. Okay, they've given us the start signal. Um, and so this is about a whole bunch of things. It's about PostgreSQL, obviously, because we're at that kind of a conference. It's about REST APIs, about rapid application development. And although I say for legacy data, it doesn't really matter if you're starting from scratch, it still applies. Most of what I have here applies to that. So okay, I'm Charles Finley. I've been around the block a few times. You can tell by the gray hair. I've worked with all kinds of different systems. Mainly what we do right now, though, is we take older applications and data sources, and we do modern things with them. You'll see some examples of that. But we do replatforming. In other words, we can take an application that's 40 years old and runs on an obsolete platform and make it run on Linux as though it was always there, with the users not being really able to tell that we replatformed it. And we do language conversions, just some obsolete programming language will make it exist, to where the program's still working in another environment, usually in a Java-based environment. So that's mostly it. I just want to define two terms. The first one is migration. By that I mean we just actually move the data, and you'll see the APIs to another platform. So a good example is it used to run on a Hewlett-Packard 3000, and we make the application and the data run on CentOS or Red Hat Linux, that sort of thing. And modernization is another step. So users today want things to run in a web browser. They want to be able to use their mouse. They want to be able to get mobile access to data. They want to be able to reach out, even though this application was written 40 years ago. They want to maybe use Google Maps, or they want to do payment gateways. And we know how to do that. So that's included in our goal and our way of thinking. So that would be modernization. But modernization goes a little bit further, as you'll see, in that one of the things I like about PostgreSQL is that your original data sources may have been written for ISAM without referential integrity, without foreign keys and things like that. And so that would be included in the modernization, making the database, taking advantage of the power of the database. And that's also part of our formula. So, as I mentioned, we do lift and shift. So we like to take the application and fool it into think it always ran on Linux or Windows or whatever it is, or some kind of Unix. And the modernization would be, the user interfaces and all that stuff, making them work in a modern environment. The reason we're interested in this topic is we make a living doing this sort of thing, and people have this clutter of all these old applications, DBase 2, Paradox, all these things, ISAM, all this stuff exists, and users still have some valuable data there, and they want to be able to get at it. So what we advocate is a strategy, a data-centric strategy, mainly centered around the database, that we have a progressive series of solutions. In other words, we don't want to throw out the baby with the bathwater. So our strategy involves preserving as much as is valuable in the old application and the old data structures, while at the same time advancing the prospects for the future, putting this older application or this older data source on a modern trajectory. And so you'll see what we're talking about there. But we stress developer productivity. We like to carry the developers along with the application. In other words, we're not just trying to, we like to, I don't know, people who have been developing applications as long as I have are familiar with the text-oriented editors and the COBOL development and those kind of relatively primitive ways of building applications. And what we advocate are ways to take even those programmers along with programmers who just got out of school and giving them the same kind of tools to add features to the application. So that's important. Just to give you an idea of the scope of the problem, if you go to Wikipedia, you'll see that there's 100+ kinds of relational database management systems, most of which are obsolete right now, but some of which are brand new. And there are all kinds of other, like flat file kinds of ways people have data. So we're talking about ways to deal with all that alongside the more modern NoSQL type data. So what is an application? An application consists of, an overview is, the data itself, screens, the programs, the scripts, we're not just talking about the database, we're talking about all those, and we're talking about unifying those onto a platform that deals with all of that. So, the choice of relational database management system is important. In other words, if you use Postgres, you get everything you need in order to do our little formula, our little dance. Because it's a modern database management system on par with IBM DB2, with Oracle, with with Microsoft SQL Server. It holds up against all of those, and in some cases it's superior to those. So it does matter. And then we're not just talking about professional developers. We're also talking about what some people call a citizen developer. In other words, somebody stuck in some department someplace who might use Microsoft Access to build an app, and all of a sudden 10 people are using it, and they're losing data. They have security issues and all that. We're talking about something that will work for them to prototype the application, show you what they want, so that their frustration of they don't want to wait 2 years to get their application. So we're talking about tools that work for them as well as professional developers. And we are talking about something that facilitates rapid application development. But by that I mean drag and drop and graphical, building forms, that kind of thing, and reports. And Postgres provides all that. So REST APIs. Why do I care about REST APIs? Does anybody, this gentleman over here I was talking to, why do you care about REST APIs? Well, everybody knows what that is. If you go to find tools that will use it to do mobile applications, that's what people are saying. Well, tell me what the API looks like. Tell me how to get at it. What do I need to do to talk to your API? Furthermore, if you want to use your application screen as a consolidation platform to use Google Maps or payment gateways, you're going to be the easiest way, the most likely thing that these software development toolkits will provide is a REST API. So you want something that can consume that as well. That's why that's important. So there's your database right there at the top. And here is what we're going to do. I'm actually extremely biased about all this stuff. I have done a lot of work over the years, probably the last 10 years, on frameworks, application development frameworks. And some people are on that side of the room, some are on the other side of the room. I don't think this will show on all sides of the room, but here's your database right here. And so so there's your browser on your desktop right there. And we are using a platform, in this case, the Cuba platform. It is an open source Java-based framework, and it will allow us then to take our older data. Here's older screens from an application that's 40 years old or plus, and programs. We're talking to programs that are old that we create stored procedures from, or we just use them as modules, and we can talk to them with that same REST API. So that's what we're looking for. Something that will allow us to use to access our data sources that way, and the other pieces of the application. That's our goal, and the Cuba platform will do that. So I have 3 examples that I talk about. One of them is a comma separated variable type file. Just plain flat files that are very unsophisticated, and that's kind of like a proxy to represent things like ISAM data sources or really old data sources without related keys. So where all the work that you do has to be done inside the program in order to make these things work. Then we're going to talk about Microsoft Access for good reason, which you'll see in a minute. And then we're going to talk about an older COBOL application running on a platform perhaps some of you have never heard of before. But we're going to just say that all those things can be treated with what we're talking about here. So our target environment, our development environment, is going to look like this. It's going to be this Cuba platform. Like I said, it's open source. You can just download it tomorrow or today, in that fact, and get some stuff running. We're going to talk about Postgres. And we're going to talk about an interactive development environment like Eclipse. How many people are familiar with Eclipse or IntelliJ IDEA? Those kinds of things. Okay, so we're blending our own environment, development environment, from those pieces. And some people confuse the issue by telling you that Microsoft Access is a database. It's not. It is a graphical development environment that uses a JET database engine. Newer versions use another kind of database engine, but the reason it's so popular is mainly because of the development environment. So I like to use that as an example, because the whole idea that what I care about is one developer sits at the computer and they don't consult with the DBA. They don't consult with anybody else, and they can build a database-centric application in one sitting. If the tool meets those qualities, then I like it. And Microsoft Access, if anybody here who's developed with Microsoft Access before? Anybody? Okay, pretty darn easy to get something going. It's deceptive because it's got some limitations, but it's pretty darn easy. It's fun. So we're trying to get something like that. So this foil just describes all the different kinds of things you can build with Access, the forms, the reports, the queries. And so we want something that does all that, the whole application for us at our workbench. And you can also write code. You can write procedural code. You can write macros and stuff like that. All of that at one workbench. So that's our model. So it's got advantages and disadvantages. And I just went over a lot of the advantages. The one disadvantage is that it's Windows only. Another one is that it's finite. It's one file. And when you're over 2 gigabytes or whatever the thing is, you're sunk. So I don't care how much you like this application, you can't go beyond those limitations. But it gives us a model, gives us something to aspire to. So if we can recreate those benefits by using a bunch of open source stuff, then we'll all be happy. Okay? So we're going to do that. but I'm inserting something else here called dbeaver. Okay, because remember I alluded to the fact that we want to modernize that database. So that's another open source thing you can download. So you first get your data inside the Postgres database. But there are no relationships in this particular thing you're migrating from. Let's say it's ISAM files or flat, just some kind of flat files. So you want to create foreign keys. You might want to create views. Views solve a lot of problems because they can embed, like join some tables together and give you the subset that you want to work with. Or stored procedures, you might want to take this bundle of functionality, this magic thing that tells you, in the case of a hotel reservation system, it tells you how many rooms are being reserved and the status of all your different rooms. You might want to just bundle that into a stored procedure and allow a person with one SQL statement to be able to pull that information out for a web system. You can do that with Postgres. It's got the stored function, stored procedure kinds of things on it. So, but you need a tool that helps you build that stuff. And so I'm just saying that dbeaver is one of those, and it's open source, it's free. There's an enterprise version, but it's amazing. It's an awesome tool, and it deals with everything that I'm talking about here, all my examples. And then the Cuba platform with Cuba Studio and the Eclipse IDE. So here's a Cuba Studio. Let's see if we can get this video to work. Oh, so what's happening here is this shows you how, I'm biased towards this side of the room, I guess. What happens is, and you can, all this stuff is available when you download the presentation. But this is going to show you how easy it is to build an application in about 2 minutes from an existing data source. So let's say you have this Access database or this DBase database or whatever, and you get it to where you have these relationships defined. I'm not kidding. In 10 minutes, you can build, or like in some cases, I guess if it's small enough, in a couple of minutes, you can just go ahead and build this fully functional application that I'm showing you, where you have CRUD operations or SCRUD, search, create, delete, whatever, updates and all that stuff against the database. It actually works. And it generates this beautiful Java code, which you can then enhance if you want to, if you need to. In many cases, that's all you want to do. You want to be able to update the tables. So this is an example of Studio that does that. And then it also propagates the code to an Eclipse IDE or an IntelliJ IDE. So that's what we were after, and that's what we have here. So, okay, so there's a timesheet example here that you can download with the Studio, and it goes further, and it's a more substantial application. I just gave you a reference to it, so it'd be a good thing to play with if you download this Cuba Studio. It's important to note that it's just kind of a setup. It allows you then to create this code generation thing from the database. And then, like I said, if you want to write procedural code, then you actually, it links to an IDE, and then you can actually write your procedural code. But this example shows some of that. And these people at the Cuba, who sell the Cuba platform, have some really good manuals and tutorials and things like that show how that stuff goes together. So there we have both the Cuba development environment or the Studio and the IDE in the background. So that's what we were aspiring to. So the Cuba REST API is, you don't do anything to set it up. All you do is you put your database in it, and you have a REST API available, and you have good documentation on how to get at it and how to create your own clients in order to use it. So you got to do nothing for it. And then you have a variety of clients available to you that you can use, just mobile only or desktop or web clients available. It's pretty slick. It's the best thing I've ever seen. You know, form designer, things like that. And I'm not going to show this demo of actually going through using Postman, but that's a Google Chrome-based client that allows you to navigate your API. So what you can do then is all of a sudden, by just putting your data in this with this Cuba framework, is you have created the ability for outside applications to get at those parts that are exposed through this. And you can extend it. It's extremely extensible. Okay. So now, that's what we're talking about, a database-powered application builders, and in my case, adapted for migrating and modernizing legacy database applications. So the main tools here, all right, so if you don't have existing data sources that you're worried about, all you need is the top part. But in my case, we have all these different desperate data sources that we have to deal with. All this junk people have accumulated over the years, some products that are totally abandoned. So we add little tools, we call them Transformix tools because that's the name of my company, that allow us then to make use of this Cuba environment to our advantage. So we have migration tools, we have modernization tools, integration tools, and various services. And the model we follow, though, is that here's your program and your data sources to start with. And then we have this intermediate step right here where we may migrate the programs. Sometimes all that means is that in the case of Microsoft Access, you just point it to a Postgres database. And that's it. Now all of a sudden it's using that instead of its JET database, and you have accomplished a lot. But in some cases you actually, and in most cases we worked with, well, not for these legacy applications, we might actually take a whole bunch of COBOL code and have it now all of a sudden accessing a Postgres database. And the user's world is totally redefined. And they can stay in that state forever, or they can then transition to a thoroughly modern environment in their own time. They're in control. They're not going to get, worst case, they end up with what they had before, running with a Postgres database. So there's no downside. There's no bet your business kind of situation here. So that's what we're aspiring to. Okay, so here's a whole list of all the different features that we're getting out of this equation. So we're getting the database, we're getting the ability to modernize the database out of all these things I'm talking about. We're getting the ability to do code development, to do coding if we need it, and you know, the web development. Here, and I'm showing this in just comparing it to Microsoft Access and showing how with this Cuba Studio, we go beyond that and we add some other capabilities where with the REST APIs and all the different platforms we can run on and that kind of thing. So with unlimited potential for expansion. So this is, our customers tend to start out with this legacy platform. We migrate them to an intermediate state, and like I said, they may actually coexist in both that state and develop new functionality side by side. And they don't ever have to go away from that model. They don't ever have to then throw away the old code. And I'll show you some insight into how that, how we accomplish that. So various stages here. I won't waste time on that particular foil because I want to get to this. This right here, it shows all the different kinds of clients we can have with this environment. And these client types come mostly from the Cuba framework. So like I said, you have the things like AngularJS, you can have that sort of thing. You can have desktop clients, Java desktop clients, you can have web browsers. All of these things you get, okay. However, what we like about it is we take these legacy screens and programs and we can attach to them and create RESTful APIs for those. And so we can build this new application framework that incorporates some old programs and some new programs and let the customer decide what they want to use when. The most likely scenario, the most favorable scenario is to modernize the look and feel of the screens. You know, in the case of really old applications that run on dumb terminals, that's what people want. But they also want the database and being able to use SQL against the database and the REST APIs. So that's the kind of thing we do. And so here is an example of one project we're working on right now, where this is actually using COBOL programs in the background. And the users can't really, I mean, and we can do all kinds of enhancements to the application without violating the integrity of the original COBOL programs. So what we're doing is we take the forms file and we control it from this Cuba environment. So, real world example there. Okay, so now we get to another part right here. I don't know, probably there's Linus from the Peanuts cartoon thing. And he's saying there's no problem so complicated or so big that you can't run away from it. And that's what this is about. We're running away from the problem of programming and having to do a whole lot of work. So this is our motto right now, code avoidance. Avoid coding until absolutely necessary. Only write programs that you have to write. And that's my overriding philosophy. So RDBMSs are good at a whole lot of things, and I won't bore you by reading it all at you, but we want to use the RDBMS to our advantage, and Postgres is a real good example of that. But the whole point here is that there's a whole bundle of functionality that you get out of just plain using a good database management system. Some people say that 80% of, and some of you in the room have written programs like this, 80% of your code has to do with you know, just accessing the files and updating and doing verifications and things like that. And if you use a relational database management system, the database can do that work for you, and all of a sudden your programs are a lot smaller. So that's what we're after from the RDBMS, and Postgres is an excellent candidate for that. So then the framework itself, the Cuba, as I mentioned, these frameworks, we've gone through Savoy, I don't know, Open Legacy, Axelor, all these different Java-based frameworks. And they all accomplish this. What happens is there's all of this code right here. If you look at what the kind of code you have to write for traditional programming versus with these frameworks, the frameworks do a lot of the work for you. And if you start playing with this Cuba framework, you'll see how much code is good code that's generated for you behind the scenes that you can then modify and enhance. So that's what we're after. So that's the next stage. And then the IDE. For those of you who have used Eclipse, you know how you know, the debuggers and all this stuff, all of these, this power it gives programmers, code completion and all this, that it does for you to make your job easier. So we're trying to reduce the amount of work necessary to do our jobs.
I'm all about that bass,
I had to do this.
No trouble. I'm all about that bass, about that bass, no trouble. I'm all about that bass,
Little poetic license here. to talk about the database. Popular song by Megan Trainor there.
I'm all about that
Oh,
bass,
I was trying to move
no
on here.
trouble. I'm all about that bass, no trouble. I'm all
There we go. So here are the steps that we go through in modernizing the database. We want to, on the first hand, just get it over there, just migrate it. And then we want to do data validation within the database. Those are, like for example, these old data sources, you may not have the ability to store date types. You might store those as alphanumerics. So what we do is we actually use the native date types, and we fool the program into thinking that they're still getting the alphanumeric types with the little tools that we use in order to wrapper around the relational, the older API. But new programs, anything that you want to use to develop, can take advantage of the date types. Referential integrity, the foreign keys, primary keys, and then, like I said, views and partial key searches, composite keys, all those things you can do, and that's modern, and stored procedures, and that's modernizing the database. So that's what we do with the database. And then, so I mentioned that we had some examples of the different kinds of databases or data sources, and what kinds of steps we can do in order to get them into Postgres, and what we have to do to make them all work. And anyhow, I think this is kind of redundant with what we've talked about before. But the point is that no matter where your data is today, you can get it into this environment, and Postgres is an excellent candidate to then take advantage of something like the Cuba framework. So this is just a picture of dbeaver, and even for flat files, for comma-separated variable files, you can actually, you put them all in one direction, you point to them, and it treats them all like they're part of a database, and you can get visibility over them, you can edit them, things like that. That's why I like the tool. Okay, so again, flat files, we use Postgres and the Cuba framework, Microsoft Access. So this is the classical Access Northwind database. So what we did is we actually just show an example, and I intended to have it all done to where you could actually see this. You could download these examples online, and I will have that shortly, but I didn't. I ran out of time for getting it all done. But these are real examples of things that we know how to migrate and modernize. So now you see the before and after, and this is actually running against the Postgres database in the after. And then this is the Cobalt Turbo image. This is like a 40-year-old technology, and the way that we go about moving it into the modern world, and REST APIs and all that stuff. And this is live. This is real stuff. And the Cobalt programs still work in the target environment, but the user has modern screens and stuff. And so here's another example with the Cuba platform. This is, if you download the presentation, you'll see this example. So anyhow, so the whole point is to make your applications evolve. You don't have to do all or nothing. You can gradually improve the application's ability to meet the organization's needs with these tools that I'm talking about. And these are all things that you can download yourself and play with. And I would recommend that you do that. so that you can see the power in all this. And then, so this is my contact information. The foils are available. There's a wiki where all of this entire presentation is available, and all the videos and all that work. And then if you keep watching the same location on our website, which is referenced here, I'm going to add some of this other detail so that you can play with some of our examples. And if you, does anybody have any questions about any of this stuff, or criticisms, or anybody, or about other tools that might be used that you think are better, or whatever?
So how do you, what's your estimated effort on, say, taking the COBOL program and doing it? You know, I understand the various points, the complexity of the issue, but walking through the steps from a time standpoint.
Okay, so what?
A couple of them appear pretty quick, a couple of them appear pretty stout.
Okay, let's examine your question in a little bit more detail. So do you want to, what is your goal? Just to get the application up and running, or do you want to replace the COBOL program?
Let's say
Replace the program all the way through. Okay, so it depends on the program. If all the program is doing is updating a couple of tables, then you may have to do no coding for that program, because using Cuba, it does take care of that kind of thing. You know, so all of a sudden the person's got a screen, they can update it, and if you've done the work on the database and you actually are showing the relationships, a lot of that program may actually just plain go away, the need for it. Okay, so let's take another example where you've got some complicated logic inside the program, this bundle of logic in there. You might want to look at replacing the surface stuff, the screens and and all that, and then keeping that stuff as quote COBOL. Why do I say quote COBOL? Because what we've done is we actually use Open COBOL or GNU COBOL instead of Micro Focus or whatever, because we have a lot of control over what we're doing there, and we have the source code for what we're generating. All right, so you change the front end of it. You make that essentially almost like a callable subroutine. And in the case of GNU COBOL, it's in C. We also have had to solve some problems by converting that COBOL. We have a COBOL to Java converter, and we've converted it to Java, and that's usually has to do with speed. We've had some programs that, let's say you have 600 programs in this application, and all but 5 of them work faster than they did on the original platform. But those 5, the reason they're so slow is because we're following procedural code. If we leave the program intact, it's actually reading each record to go and do something. SQL, so let's say, here's a real example. It might take 2 hours for the program to run if you have it use its old API, the read, write, and all that stuff, the COBOL stuff. However, if you change it to where it's doing SQL access, it might take 10 seconds. I'm serious, I'm not exaggerating. These are real examples, 10, 20 seconds. So those, what you do is you convert them to this kind of hybrid Java thing, and you change the database access to SQL. And so you use the tools to your advantage, and you do as little work as possible. And this Java conversion thing makes it automatic, kinda, but it might take like a couple more hours, because then you all of a sudden have to rethink. Instead of reading these files in and then writing to disk and sorting and all that stuff, you just use SQL statements, because now it's in a relational database management system, and you can do that. So it's more like that. It's a process. It's a heuristic. You're going you're analyzing the situation and you're treating each individual program the way it needs to be treated in order to get your result. Sorry to be so complicated, but that's how it works. Yeah.
I have a question about developing an application that's RESTful API.
Okay.
You mentioned Cuba platform. Do you have examples of other tools that you've used successfully, particularly given if our data is already in Postgres?
This works if your data is already in Postgres.
Okay.
Yeah, the Cuba platform.
About the main one, or is there something else?
Okay, no, what we've gone through, okay, and I can give you a more exhaustive list. I didn't try to do that. Over the years, we have evaluated lots and lots of different frameworks. Okay, so let's go at it strictly from our perspective, what we care about. What we needed was an environment where we could use some old programs and bolt them in, access these screens, the older screens, and incorporate those into the application. We needed something that we could do the integration with. And we found that the Java-based web application platforms were best. I mean, because you can do PHP, you can do Ruby, you can do all these different kinds of things. So for us, the Java-based platform was best. So looking at those, we've gone through Servoy, Convertigo, we've gone through Axelor, we've gone through Open Legacy. All of those things work and are good for a lot of things. But then we needed also the ability to be able to do that access-like thing. Rapid application development, doing drag and drop, and being able to create forms and put widgets on top, or some people call them controls. So we needed the ability to be able to take an application and build it really quickly if we were building it from scratch. And so Cuba is the evolution. It combines all the things that we like. Furthermore, if you dig deep, you're going to say, oh, well, all these types of frameworks have essentially the same pieces underneath. They have some kind of a JPA for building objects that access the database. They have, all these things. They have standard stuff. They might use AngularJS for doing the mobile screens. So you start looking at all of these standard kinds of features so these frameworks are a combination of stuff that everybody knows about, and also you end up with a REST API, and that's how they were actually talking to the various objects. In the case of Axelor and Cuba, they don't actually generate code for the screens. They actually generate XML files, and they render the screens at runtime. They give you the flexibility to rebuild the screens, re-architect the screens. They give you the ability to integrate things inside the screens from the outside world. So if you start looking at all those qualities, which I don't have an exhaustive list of, we evolved in open source. The problem we have is that we run into corner cases where if we have closed source things, we have to do a lot of work. We have to do 2 weeks worth of work in order to avoid some kind of an issue. Whereas if it's open source, we can either look at the code and see what's there and work around it that way, or we can alter the code to make it, to avoid that 2 weeks worth of work. So what's good for us may not be the best thing for you. Also, we have clients with Oracle, we have clients with DB2, we have clients with Postgres, we have clients with Microsoft SQL Server, and we need all of that. We need the ability to deal with all of that. So I don't know what all your criteria is, but
We have sections in PHP, so we've looked, for example, at code igniter. I don't know if
yeah, I've seen, yeah.
that might work.
Also, the thing is, if you're just looking for a REST interface without any
Right.
graphical screens at all, without any multi-platform,
No, there's a lot of choices there.
there's much lighter weight tools like
There are.
PostgreSQL.
Yeah, PostgreSQL. Yeah, I know what you mean. I've used it.
All that does is provide you with a REST interface.
On the database. On the database itself. If you have other objects you care about,
Is that
It's open source. You download, it's magic. It works really easy. It's beautiful.
It's a little Haskell web server that actually just supplies REST access.
Yeah, but you can get something going really quickly. If you also look at, there's an admin tool also that is, oh, I'm thinking NPM, that's not it. Node.js. It's based on Node.js that lets you see how the screens look and all that. So, but it doesn't have the studio front end, and it doesn't have this ability then to add your own code down. You know, it's harder to work with for what we need, but it might be fine for what you need. Yeah. Okay. So, any other questions or? We've got 5 more minutes, so if there's anything you want. Okay. Well, good. Well, thank you for coming, and thanks for the questions. Yeah, I hope you got something out of this.